time we were fighting our way back from the front line in the Lacatosian retreat to the theory, and I guess I had got to the distinction between the hard core and the periphery of a theory, which I said Lakatos does not discuss, because he lumps everything except the hard core as in what he calls the protective belt, which protects the theory, the hard core of the theory, from being destroyed. I'm afraid, thinking back to last time, I didn't clarify one point that's rather important. Lakatos isn't clear about this in his writing, although I know he was in his conversation. When one is engaging in this Lacatosian retreat or Lacatosian defense process of the theory, whereas in Lakatos's example, the theory, the hard core of the theory is taken as being true, and that the theorist is operating on the assumption that it's going to turn out to be true. That's not necessary. As one conducts the Lacatosian defense, one may either be conjecturing that the theory is literally true, or one may be conjecturing that the theory is literally false, but has a lot of verisimilitude. And the way in which one conducts the Lacatosian defense wouldn't be much affected by that. That is, until you reach the theory T, the way you play the game with the other stuff that we had up on the board there would not be appreciably different depending on whether you thought the theory was literally true or only thought that it was a good approximation to the truth. So we have T and the auxiliary theories and the Ceteris paribus clause and the auxiliary instrumental theories and the specific conditions, all deductively entailing the conditional relationship that if O1 holds in the lab, then O2 holds. And we've got this embarrassing situation that we observe O1 and the denial of O2. So this is false. So this is all false. And now, if we have at least admitted the protocol into our corpus of beliefs, which might be our first line of defense, I remind you. We don't think that the rat actually did what is said. But if we admit the protocol, and then we challenge these things, and which ones we challenge depends on how things look. Depends on, for example, how well the theory is entrenched and how many domains. But we have these reasons for thinking this is a pretty plausible culprit in psychology. And this is a plausible culprit, but we'd like to preserve our auxiliaries because of the fact that the theory got money in the bank by using them. And so we don't want to screw up something to fix something else. It's as if, it's kind of hydraulic. It's as if I push this down like in Laurel and Hardy, and this thing goes, I push that down, and then this pops up. And that's the situation that the theorist is in when he's conducting a Lacatosian retreat. Now, within the theory itself, I don't want to go into details about how you separate the hard core from the peripheral portions of the theory itself, which I'm currently struggling with and trying to write a paper about. And maybe it's all wet. So let me repeat what I think I said last time or the time before, that a rough first approximation would be that a postulate which occurs in every derivation chain to all of the experiments that you perform is part of the hard core. Or another way to say it is that a concept which is relied on implicitly in all of the derivation chains is part of the hard core of concepts. See, there are concepts and there are statements. The statements are composed of concepts. One might, for example, say that a core postulate is either a postulate which appears in every derivation chain, or it's a postulate that consists only of core concepts. whereby a core concept we mean one that appears at least implicitly in every derivation chain. In a Hull's learning theory, for example, the habit strength postulate, as I said before, wouldn't appear in deriving every experiment explicitly, but the idea that you had equalized the rats where you're studying drive or stimulus generalization gradient, that you had given them the same number of reinforcements is taken for granted, and if the experimenter didn't mention that, it would be not only bad reporting, it would be a form of falsification, wouldn't it? So that means that habit strength is a core concept, even if I'm studying reactive inhibition or drive as a multiplier or whatever, or inhibition, so on. Since habit strength is a core concept that I will be using in every experiment that I do with the rat in the box or the maze, and since the way it gets to having a certain habit strength is by Hull's simple positive growth function postulate of how habits are reinforced, that means that that postulate is core, even though it doesn't explicitly appear in all the derivations. One has the notion that in fields like psychology and maybe in some of the biological sciences, that there is a bigger mess of stuff in the periphery in relation to, yes, in psychology and the biological sciences, there's more stuff in the periphery in relation to how much is in the hard core than is true of physics or chemistry or astronomy. That's just my impression. I can't prove that. That's an interesting thing to think about. As we have more, in different experimental designs, there are more other postulates slopping around that we need to do our derivation of the particular experimental finding, whereas in some things in physics you have the basic principles of mechanics and the principles of thermodynamics and the electrostatic principles and so on, and they recur, and those fundamental ones keep being used or presupposed throughout. That would be interesting to study, to sit down with a random sample of experiments in various sciences and make explicit what the investigator is assuming. I say make explicit because it's usually not presented to you in that way. That's no criticism of the logical positivists that they said you should parse it that way. The scientist doesn't bother because he's writing for other physicists and he knows that they assume the second law of thermodynamics, so he doesn't mention it. Well, I think that's enough on the structure of the Lakatosian retreat. And then I said that the justification, not very Popperian word, but I'll use it, for doing it is the track record. That the theory has a track record of having made high risk or low probability predictions in which it either succeeded or almost succeeded. Almost succeeded. Don't think that almost succeeded is only for poor primitive sciences like ours. Almost succeeded is found in many different sciences, including the ones that we all worship and adore, like physics and chemistry. Long history of things being almost but not quite. And in our Avogadro case, the fact that one gives us 5.9 times 10 to the 23 and the other one gives us 6.3 times 10 to the 23 does not lead us to reject the theory that there are molecules. Close enough is a damn strange coincidence. So I want to repeat that you do not have to buy the Popperian philosophy of science to emphasize the high-risk aspect. You do not have to believe that there's only falsification and never confirmation. You do not have to believe there's no such animal as induction. I mean, that's one of the things I think Popper never should have said, but he's stuck with it, and he really apparently believes it. A person who is an old-style inductivist, a la Reichenbach or John Stuart Mill or a Bacon, for heaven's sake, could invoke Popperian risk, not calling it risk, but calling it, like salmon, a damn strange coincidence, or like scientists have always said, even those who didn't philosophize, this theory is remarkably detailed and precise in its predictions. All right, so the warrant for doing all of this, which sounds like a big fat rationalization if you're a simplistic operational empiricist, you say, well, I was taught in Psych 1-2 that the whole operation is sinful. I mean, you're just defending this crummy theory up against the evidence. Well, you have to read the examples in Lakatos and Feyerabend to see that is something that good scientists have always done under certain circumstances and frequently with profit. I gave you some examples such as Mendeleev. What keeps us from being a priorists who are not respectful of data, what keeps us from being metaphysicians or very vague pseudoscientific speculators is not that we throw in the sponge as soon as we get a bad fact. That's not what does it. What does it is that we conduct the Lakatosian retreat in accordance with certain principles, I won't say rules, that we make it tough to ad hoc, that we make the ad hocery honest, that we intend when we ad hoc something that we or somebody else should test the new conditions as ad hoc, and that we play the game honestly. In other words, the Lakatosian defense is a defense, but it shouldn't be a fraud. If you get to the point that you say, I'm going to cling to this damn theory, whatever happens, come hell or high water, I'm going to be an orthodox Freudian about the libido, I don't care what experiments, I don't care what the patient says, then of course you are not playing the scientific game anymore. And there are other games beside the scientific one, and so if you want to play some other game, the metaphysical game or the theological game or the political game or the journalist game or the literary criticism game, that's fine. It's a free country. It's just that one should be clear what game he's playing. And that's the way Lakatos puts it. He says if a scientist really wants to fight real hard for this theory, we know in the history of science that it has at times been useful to do that. And if he's got the kind of maverick mind and the character strength to take all the flack, let him do it, as long as he reports the record honestly, as long as he doesn't try to fool people, especially his students, into thinking that the theory is doing great guns when actually it's ready for the last rites. But he is going to try to revive it. Well, now, given that ground rule that the justification or the rationale or the warrant for engaging in this Lakatosian defense is that the theory has money in the bank and that it gets money in the bank from an accumulation of damn strange coincidences. I want finally to go to a list of things that apply specifically to psychology. I dare say you thought we'd never get to that. And the last paper on the first page, P. Meehl, Appraising and Amending Theories, the strategy of Lakatosian defense and two principles that warrant it, is about ready to, well, I have sent penultimate draft to the editor, and if he takes it, and he probably will since he invited it, although that doesn't always work. That doesn't always work. I recently co-authored a paper that was by invitation of Science. The editor of Science invited it, and God almighty, the flack we got from these stupid referees is beyond human belief, and incredible. It's incredible. What a bunch of dummies. So I don't know when that'll come out. There hasn't been any issue of it yet, but the first issue will be shortly, and so that should come out sometime this year. And it's going to be, this new journal has the format of behavior and brain science, where somebody writes an initial paper, sometimes a longish one, and then a bunch of people are invited to criticize, and then the original writer gets a chance to respond if he wants to. So that should be fun. All right. Well, the reading of a narrative summary in the bulletin, as I said last time, often leaves one up in the air. And I have asked around. I don't have a questionnaire on this, but I have asked around among my colleagues because I think sometimes I'm overly critical, or that studying too much philosophy of science has corrupted my intellect. And my reaction is not highly atypical. If you ask the professors around this department, when you read a review of research in the Psych Bulletin in the soft areas, do you generally end up with a fairly firm feeling of conviction, either that the theory is no good at all or that it's peachy keen and it should be retained and refurbished? My reaction is not atypical. Now, it may be a little extreme in magnitude, but the feeling of, yes, I read this article in the Bulletin, I tried to be fair-minded, the reviewer was not a fanatic, he seemed to be objective and scholarly, and he has reviewed 178 papers on Meehl's theory of schizophrenia, and by God, I don't know what I think now. I didn't know before I read it, and now that I've read it, I don't know what I think. Very common reaction. So the question is why? What is the reason why we have this feeling of cognitive discombobulation, confusion, furriness? What do I think? Now, I'm confining myself to the soft fields, and by which I mean clinical in its theoretical aspect, counseling in its theoretical aspect. I want to set aside the technological aspects of those two fields because we are talking about corroborating theories and not about validating instruments or procedures of healing. The same problems can arise to some degree, but the acute problem arises when you're talking about corroborating theories. If somebody does a meta-analysis of modes of psychotherapy, like Glass and company, Smith, Glass, and who is it, Miller? You can end up concluding that psychotherapy is efficacious and state an average value for the effect size, and also say that the differences are not great between the modes, but if you want to look at the ranking of the modes, it looks as if cognitive behavioral fused now increasingly comes up first, psychodynamic second, and others running down to primal scream or gestalt toward the bottom. So I'm not talking about technology, whether pills work, whether there's one method of teaching fractions with little kids works better than another, or stuff like that. We're talking about corroborating substantive causal theories. And in the soft areas, I'm including clinical, counseling, personality, social, community, and school, and quite a bit, but not all, of developmental. I am therefore counting physiological, behavior genetics, perception, animal learning, so forth, as in the quote hard. So what I have to say applies to the soft. Now, Dave Licken thinks it applies to the hard as well, and we haven't been able to agree on that, and I don't know whether he intends to propagandize you to that effect, but that's fine if he does. That's okay, but don't attribute that view to me. I am not contending that these objections hold across the hard fields. He makes a good case, but the biggest distinction that's involved is that in the hard fields there are many more examples in which you do not rely purely on correlational data, but rather on experimentally manipulated data. And the point there is that you impose randomization on what happens, and that is a crucial difference. One may recognize that we can't always do experiments. Certainly I, as a clinician, recognize that. It's not only because we can't ethically or politically do certain kinds of experiments. It's that some kinds of experiments might not be very illuminating. I mean, I don't know how illuminating an artificial phobia, which has been used a lot, is with regard to, say, Freud's theory of hysterical phobias. In fact, you can even raise the question how illuminating is with regard to treatment. But Licken thinks that the factors I'm going to list here, including the crud factor, play a part in the hard fields as well, in situations where you were doing experiments rather than having to correlate the subjects as they come to you. He may be right about that. I just wanted to be clear that it's not my thesis. I don't deny that thesis. I just don't assert it. Well, I'm going to confine myself further within the soft fields to cases in which the data are correlational rather than experimentally manipulated, or cases in which, while we did an experiment and assigned subjects at random to a procedure, that the point of our experiment was to study the interaction between an experimental factor and an individual differences factor, a factor of demographic, trait, or status nature. As in my example of trying to make students anxious by telling them they flunked, and we're going to correlate the change in affiliation on the TAT with whether they're introverts or extroverts. In those instances in which the whole point of an experiment is to study the interaction term in the analysis of variance, and the interaction is between the experimentally manipulated factor and the IDs factor, race, sex, IQ, introversion, schizophrenia, or whatever, something that the subjects bring rather than we give them a dose of penicillin or we teach them fractions in a certain way. My concerns, my worries here apply to those experiments as well. So the whole subject matter now for the next 3 sessions, or maybe more, is going to be experiments, correlational studies, or experiments in which the interaction with a trait variable plays a crucial part in the soft fields of clinical, social, personality, counseling, school, community, developmental. So to what extent these objections apply to rats in mazes, we will leave aside. Well, I find in reflecting on my puzzlement when I read the bulletin article that I can discern 10 obfuscating factors at work. 10 things that are present more often than not, taken singly, and some of them are almost always present, and there are some areas in which all 10 of them are present in practically all of the experiments. And that these 10 obfuscators are, first of all, not likely to be negligible in size. They are of non-negligible size, and sometimes they're pretty fat obfuscators. They're very rarely negligible, that you can confidently write them off and say, well, this type of research, this particular one, you don't have to worry about that. They're not negligible in size, so I'm not making some sort of a compulsive anal statistician's complaint here. I'm not, those are perfectly good things for the mathematician to fret over, like should you have used a one-tailed or two-tailed test, or how should we pool these sums of squares, or should we take some of these higher order interactions that we can interpret and put them in the basement of our F-test and so on. Those are perfectly valid things. That's the statistician's ball game, so of course he plays that. But that is not what I am doing here. I am not making a piddling anal complaint that somebody didn't have exactly, he used 37 instead of 38 degrees of freedom or whatever. I'm saying that these factors are not negligible, and sometimes they're quite sizable. Secondly, they vary from one study to another individually as factors. A given one of these obfuscators can be a huge one in a certain study, and a middle-sized one in another study, and an itty-bitty one in a third study. Thirdly, they are usually not accurately judgeable in a study, although there are exceptions to that one. And finally, alas,
they are frequently in opposition to each other, in the sense that some of these factors tend to make good theories look bad, and others have a tendency to make bad theories look good. Now, any one of these things would make you a little nervous, but when you got this together, you say you got 10 factors, not of negligible size, varying from one study to another and from one domain to another, frequently not accurately judgeable, and pulling and hauling in opposite directions. My conclusion is that it's the presence of these 10 obfuscators, non-negligible, countervailing each other, varying in magnitude, and often not accurately judgeable, that leads to this intellectual fog that one experiences in reading a bulletin article. That you are not confused because you're not good at analyzing things, and that you're not confused because somebody didn't do a meta-analysis, because I agree with Chow that meta-analysis is not very appropriate for testing theories, and I know that Professor Glass agrees with that. I don't know that he has said that in print. I think it's pretty strongly suggested in the main book that it's intended to aim at technological problems, but I know from correspondence that he agrees that meta-analysis is not primarily useful for evaluating the verisimilitude of theories. Now, there may be some variant of meta-analysis, something that acts like that, that is, that does statistics over experiments as the unit, that will do it. And in my Appraising and Amending Theories paper, I have propounded two goofy forms of meta-analysis for getting at the Salmonian coincidence thing. They really are kind of goofy, especially the second one, but what the heck. You might as well let your hair down. All right, so now I'm going to go through these 10 obfuscators that make it hard to interpret a narrative summary of research on a theory, and a detailed treatment, more than we'll do here, is in the paper right before that, in Press, Why Summaries of Research on a Psychological Theory Are Often Uninterpretable. That's been in press now for approximately 2 years, and due to authors not being compulsive like Meehl, they didn't get their stuff in on time. I have had a holy oath and blood from the editor Snow, or no, from Wiley, that 1987 would be the date. In January of '88, I wrote him a letter and said, how should I cite this thing? It said, eternally in press. And he writes back and says, 1988 is solid for sure. And 1988 has passed. And so now I'm going to write him again and say, how should I cite this? What year? It's really scandalous, and it shows that editors do not believe in the laws of learning, namely that organisms will damn well do what they have to do to get what they want. I mean, if you tell students you have to take your prelims in 4 years or you're done, they'll do it in 4 years, unless they break their leg and have schizophrenia. If you tell them, well, maybe, then they'll take 6 years, you know. And even psychologists act as if they didn't believe in the laws of learning. If I were editing a thing like this, I would say, I'm sorry if your wife gets schizophrenia. That the world, as President Kennedy said, life is not fair. The deadline for the damn manuscript is March 1. If it comes after that, I will burn it. And if they believe you, they would get it in March 1. It's only because they know that you're a rat on a crummy schedule and that the experimenter is, you know, full of the milk of human kindness. But actually it's unethical because it punishes the people who do the job on time at the expense of the slobs. Well, anyway, we'll see. I mean, I don't know if the damn thing will ever come out. It took the Schilp volume on Carnap's philosophy 10 years from the date that it was supposed to come out. So I've saved you some grief now. I'm telling you stories about how the Academy works, or more I should say how it doesn't work. So we'll see. I mean, it's a good paper. All right, number one, first obfuscator. The fact that the derivation chain that we wrote down there is loose. That in psychology, it is almost unheard of that one literally writes down all of the postulates of the theory or all of the auxiliary theories. I am not saying that people ought to do this. I am simply making the point that we do not. I think I mentioned before that the only reason any of you would want to go back and read Hull's 1940 book on rote learning to realize the extent to which this first obfuscator is true obtains. Because in that book, Mathematical Deductive Theory of Rote Learning, since he hired this full-time PhD in logic to look over his shoulder and see to it that everything was all explicit per the logician, he ended up with everything being explicit. And it gets quite boring and tiresome, and it's also impressive how much you have to assume. And don't forget, this is people learning nonsense syllables, for Pete's sake. This is not Freud's theory of neurosis we're studying. And yet, when you start trying to formalize and make explicit all of the assumptions needed to derive the various curves and get the Lepley hypothesis and this and that business, it's very impressive how much is normally left unsaid. Now, when we rely on either common sense, Bubba psychology, clinical experience, or intuition to plug in some auxiliaries, that means that the logical chain that's represented by this very strong sign here of strict deduction or implication is fuzzed up. It's a sort of a fuzzy implication. Logicians used to draw some arrows with a little p. The late Grover Maxwell was always doing that, and I'd say, Grover, what the hell is that arrow with the p? Well, he says it's probabilistic implication. And I would say, and what is probabilistic implication? Well, Paul, it needs to be explicated. But I don't believe in probabilistic explication except when you're doing the whole thing statistically. But I'm out of step with a lot of philosophers of science in that regard. I think the reason that people allowed themselves to draw an arrow with a little p on top of it was that they were taking for granted the Ceteris paribus clause. Yeah, those of you who've taken some philosophy are probably aware that there's a whole movement, especially among the ordinary language philosophers, you should pardon the expression, to the effect that we never have explanations in a deductive sense, and old Hempel and Oppenheimer are full of baloney and should have been shot at sunrise, but they never give you their account of what this explanation is when it's not the deductive model. Now, my account is that it is the deductive model if you make things explicit and put the Ceteris paribus clause in. It's because we don't like to write down CP, because in soft sciences we know it's not likely to be true, that we think there must be some other way of getting from A to B that's not deductive. And my view is that of Popper. There isn't any other way of getting it. You're kidding yourself if you think there's another way of getting it. But the appearance of getting a complete explanation that's not deductive, I maintain, is due to not mentioning CP explicitly. I really don't know how I would deduce, for instance, a quantitative prediction about rats in the T-maze if I didn't write down the sentences and show that something follows from something else. I've never been able to get an ordinary language philosopher to explain to me how he does it. Any more than I've ever been able to get them to explain why they want to analyze ordinary language, for that matter. I mean, who cares what my grandmother meant by free will? She didn't think very deeply about it. To hell with it. Anyway, I'm going to take this as deductive in a developed science as long as CP is put in. As long as CP is put in. And the point is that even in chemistry and physics, it is not customary to write down all of the statements that you're going to rely on in showing that the experiment you're performing comes out such and such a way if the theory is true. The list of things that you don't bother to write down in soft psychology is presumably a good deal longer list than the ones you don't bother to write down in behavior genetics, and that's longer than the ones you don't bother to write down in deriving something about chemistry. But all scientists do it, and I repeat, I'm not saying, pointing the finger and saying anybody's wicked for doing this. I'm just saying this constitutes an obfuscator, and it gets to be a worse obfuscator the more such things are left inexplicit. All right, a second one, obfuscator, is that the problematic is that the auxiliary theories, when explicitly stated, so we do have them in a deductive chain, are problematic. And I guess I don't need to elaborate that one because I've given several examples, like in the TAT case. The auxiliary theories, part of your science, not part of some other discipline like chemistry or electrical theory or something. Part of psychology, a theory about how the Rorschach works, a theory about the construct validity of the multiphasic PD scale, a theory about language in relation to perception, psycholinguistics. Think of all the experiments we do, and we at least have to assume that people can tell us what they're seeing. I mean, how far would some perception experimenters get if they took that itself as being highly problematic? And of course, in the great days of the introspectionist school, Wundt and Titchener and those characters, and then the Gestalters in the 20s, they fretted a lot about this. They worried, for example, Titchener always wanted to have fully trained subjects. And that meant trained to the point that certain kinds of Gestalt effects didn't occur to them anymore. Whereas Kohler, Kafka, and those fellows said, all Professor Titchener means by a fully trained subject is one that he's brainwashed in his lab at Cornell so that they don't see stuff the way people usually do. And the problem of the relationship between a verbal description and any sort of complicated perception, visual, auditory, and so on, is not a minor problem at all in psychology. So we have problematic auxiliary theories. If we're doing research in psychopathology and we're using a tachistoscope, studying reaction times to dirty words or something like that, like in Burns' famous study, we have to make certain assumptions about reaction time and about vision and about verbal behavior and so on, which, when made explicit, may make us quite nervous. That is, they could make us nervous in the sense that this auxiliary at this time really isn't any better corroborated than T. And so I'm engaged in kind of a funny operation here. I'm subjecting T to a Popperian risk via auxiliary A, and it's like the X-ray crystal example I gave you. One could just as well worry about whether the auxiliary was all right. I remember when I was in graduate school giving a talk in Dr. Hathaway's seminar on a study of the Rorschach in twins. And I was one of the few clinical students who had a soft spot in my heart for the Rorschach. As I look back, that was a mistaken thing, but anyway, I did. And Hathaway thought the damn thing should be burned. So we got into a big discussion about whether this study was a study of genetics or a study of the Rorschach, because she had shown, I forget the psychologist, it was a kind of a cute study, and it involved getting the resemblance in the determinant profile between monozygotic and dizygotic twins. There was a lot of argument about how she did the index and so forth. You know how that would go. But aside from that stuff, if it turned out that the similarity in the F little c column, it was Klopfer scoring, if the similarity in the F little c column of MZ twins was greater on the average than with DZ twins, and if some other thing didn't show a difference, are we saying that that other determinant, say the Erlebnistypus, didn't pan out? Is that the Erlebnistypus is not very much genetic? Or is it because their Leibniz typus is a crappy measure that doesn't get at anything? And of course, at that time, as is true no doubt today, one does not know the answer to that question. Arguably, if some of the determinants showed a markedly greater resemblance, closeness between MZ and DZ twins, between MZ twins than DZ twins, then arguably you would be saying we have indicated that the kinds of things that the Rorschach taps into in temperament are genetic, and consequently, if some of the other things don't seem to pan out as showing that MZ-DZ difference, those other things are probably not very valid indicators. But that argument won't go through, because somebody could say, well, we haven't got a big pot of things called temperament that we know are equally loaded with the genes. In 1943 or whenever this was, I was in that seminar. Of course, we didn't have nearly as much evidence for the genes affecting all sorts of stuff, like vocational interest, for instance, as we do today. But you can see how the argument would go. You would be hard put to make up your mind if you've got strong MZ correlations with the texture response and weaker ones with the human movement, and no relations, no heritability at all for O minus or whatever. Whether we should say, well, the Rorschach isn't good for this trait, or this trait is not very heritable. It's a mess. Well, I picked out assessment devices as the obvious example because I'm a clinician, but it would be true for people in other fields. You would have auxiliary theories about the input, the operations you performed. Did we make everybody nervous by saying you got a D in the mid-quarter? No, we didn't make the row psychopaths nervous. So for them, it's not going to work. And they tend to be more extroverted. And that's going to screw up the interaction term between introversion and affiliation, like that. Okay, thirdly, the Ceteris paribus clause is not only problematic, but if taken literally, is almost surely false. It's really hard to conceive of a thing we do in soft psychology that involves correlational stuff in which you could say with any confidence, and there isn't any other systematic trait of humans or any other demographic thing about them, like their social class origin or their race or their age or their sex or their religion or their political affiliation, there isn't any other that's going to be a correlate of one of the factors that we're plugging into our design. That would take a tremendous amount of chutzpah to say. This is independent of all this other junk. Consider, for example, the Gallup poll. When you look at the Gallup poll and they're asking about abortion or the snail darter or whatever, they break it down, and it's very costly. It costs a lot of money. They break it down so that you've got age, sex, social class, measured two aspects of that, income and how far you went in school, geography in the sense of north and south, Pacific and so forth, and also rural, urban in some cases, depending on the question, religion. And within religions, they should bust it finer, shouldn't they? Methodists are not like hard-shelled Baptists, and they're different from Unitarians, and so on. Well, why do they do that? Why do the social psychologists and sociologists in the polling business do that? Because it's been found over and over again that your opinions on a variety of subject matters are strong correlates of these demographic and status factors. So, when we say Ceteris paribus, let me repeat, we are not claiming that we've controlled all the variables. We know that we're not doing that, or we wouldn't have any variance left. What we mean is that the things that we have not controlled have been subject to randomization in the design, and those things that we have not been able to randomize because the subjects brought them with them, correlational things, that are in our interaction term, we hope to God are not too much correlated with some other nuisance variable that has a role in the output that we're studying. That's the crux of it. We hope to God this isn't very much correlated with some other nuisance variable. If it's correlated with one that we've got in our study, of course, then we can monkey around analyzing covariance and things like that. But you don't put in all 25 things that would be candidates or all 50 things that are candidates and take them out. So if they're being dragged along by a thing that you are studying in its interaction effect, then you have to hope that whatever is being dragged along is not like this introversion thing correlated with some other attitude to why you're in college, and hence do you care whether you get a poor grade in the mid-quarter and blah, blah, like that. My own impression is that the likelihood that the Ceteris paribus clause is sizably wrong in soft psychology mixed experiments is a worse problem than that the auxiliaries are not trustworthy. I really think that the Ceteris paribus clause thing is probably the most malignant here, but that's just my impression. I'd be hard put to demonstrate that. Number 4, imperfect realization of the particulars. That's CN on the left. That the experimenter didn't do quite what he said, or that he failed to mention something that he did that counts. Now you might think that should go under CP, but CP really refers to correlated variables that's part of the state of nature, whereas this thing refers to the particulars. I mean, it means that what actually took place in that lab by this investigator was mal-described or incompletely described. And I gave you an example from one of the hard areas, namely rat psychology, where the question is whether McCorkadale or Meehl carries the rat into the room, or how clinical Spence is about test breaking and so forth. You know that there was a flurry of studies sparked by Rosenthal's work in the, what was it, the 60s, in which it was shown, maybe not as strongly as Rosenthal originally claimed. I have not monitored that stuff carefully, but it was shown by other people in Rosenthal that there is an experimenter bias effect in terms of what the experimenter believes he should be getting, or what theory he believes in. Sometimes this was done by studying the scientific investigators involved, and other times it was done by having students be the experimenter and either teaching them a certain doctrine or selecting them for believing a certain doctrine and having them do the experiment. And it is quite clear that there is an experimenter bias effect which is observed correlationally and not always easy or even possible to ferret out how it's communicated, how it's done. If you think about experiments we do in clinical psych and social psych, where part of the stimulus input is another biped talking to you and looking at you, and reflect on the extent to which things can be conveyed by body language and by the pauses in your speech and by the tone of your voice and things like that, things that people had to worry about when they were doing quantitative research in psychotherapy. That's a real mess, isn't it? You can't, for example, assume that your research assistant, since it's not her theory but yours, has no stake in it. I mean, maybe she wants to please you, or maybe she's an ingratiator, maybe she thinks she won't get hired next year if the experiments don't come out right. Maybe she has come to the conclusion rationally, as you think you have, that this is a pretty good theory, and so on and so forth. You don't have to spin out anything very, you don't have to have a big conspiracy to hide the truth to see that Rosenthal's worry is a perfectly good one. And as is made clear by some of the recent work in the other sciences, including physics, quite a bit in the biological sciences, some of that is discussed in this book by David Hull that I suggested to you a couple sessions back. The experimenter effect is not confined to psychology and sociology. That the experimenter bias effect has shown itself in all disciplines. To the extent that an instrument of measurement is not employed, that's highly objective in how you manipulate it, and to the extent that somebody has to hold a rock or look at the chimp or whatever, where the human being gets into the system either as an input variable, as a manipulator, or as an observer, recorder, the experimenter bias effect is something that we have to worry about. I repeat, we do not have to assume anybody's being dishonest. There are instances of fake data, as you probably know. Whether there are more of them now than used to exist, I do not know. There are committees that have been set up by the National Academy of Sciences and the NSF to look into the question of faking data because some administrators of foundations and federal fund-granting agencies are thinking that the insane publish-or-perish syndrome today is leading to a greater temptation to falsify data than used to exist. I have no opinion on this matter, but there are some scandalous recent examples, yes.
Are you saying that this is an obfuscator because in the original articles the authors didn't include that information, or that the reviewer is glossing over it?
Well, it could be both. I had in mind mainly the first, that the reviewer wouldn't be able to tell some of the things that were done in the lab because the author of the paper didn't mention it. But certainly the second phase can operate as well, either because the reviewer is careless or he's in a hurry, or because the reviewer has a little bit of pardonable bias in the matter.
Yeah, so it's two parts.
So that's error superimposed upon error in that case. The correlations between people's views and how they behave as referees vary from one study to another done by the historians of science, and we really need more evidence on that score. But in the field of biology, Hull gives some examples in which it was quite clear that editorial bias had a pronounced effect on which articles were published, and that would presumably have a more subtle form, in that the editor gets to choose the referees. So the editor may not high-handedly say, I won't publish anything on Jones's theory because it's no good, but he gets to pick from a stable of referees, and they are usually people, they should be people who are knowledgeable about it. Well, people who are knowledgeable about a certain area generally have opinions about that area. There's one editor of, systematic zoology, forget her name, who had a very strong distaste for numerical taxonomy. And she was a believer in the old-fashioned clinical type, this is a sunflower, look at it. And she actually announced, I give her credit for this, instead of sending it to cancerous referees, she announced that when she was editing the journal, not more than one article per year would be allowed on numerical taxonomy. Well, I don't know how much of that stuff goes on that doesn't surface in such an explicit form, but I am convinced from not only my own sad experiences, but other people's where I can be somewhat objective, that psychology editors probably should be very careful in reviewing, sending articles that contain anything statistical to PhDs in statistics, because they are a real, anal, rigid, dogmatic bunch of bastards, and they are in the habit of treating social scientists as if they were nincompoops. See, you get that habit if you're a statistician. You're a consultant, you know. Some of my best friends are statisticians. Don't misunderstand me. I used to have two of them teaching this course. But they get the habit because there they are, omniscient Jones, in their office with their gamma functions. And here comes poor old little Dr. Glotz, second-year resident in psychiatry that hardly recognizes a standard deviation that he meets on the street. And he's seen a few of these patients, and he brings in his little mess of crummy data and says, Professor Glotz, what do I do with this, you know? And so they get in the habit of talking to social scientists who are mathematically ignorant and pontificating it to them. And consequently, if a psychologist or sociologist has an idea once in a while, he is likely to, or she is likely to have trouble getting it published. I could give you numerous examples, and I'm not just talking from my experience. I had a bad one recently, but I've looked at things by other psychologists which were on some aspect of psychometrics or probability inference and so on, and then looked at the referee. Some journals you know who it was, others you just are told by the editors he's a PhD in statistics. And they're very dogmatic, they're very rigid, very high-handed, very arrogant intellectually. And what they tend to do, and some psychologists do this too, when you get to be a referee of journals, you should not commit this sin, because it's a grave scholarly sin, is they have their set of concepts and rubrics. And as soon as they read the article, and by the time they get to the third paragraph, they know what category this goes in, and they put it in there, and they don't read the rest or think about the rest. Very strong temptation. I used to be a consulting editor for Ed Borden for about 6 years in the Journal of Consulting Psychology. And you used to have to submit, this is before Xerox, you have to submit your referee remarks with carbon so he could mail them out to the other consulting editors. And I became quite aware of my defects as an editor, and that is that my theoretical interest was so strong that I didn't always look carefully enough at the facts, and so I would pass tables that had something impossible in them. I tended to assume that at least the sum of squares will add up, you know, and sometimes they didn't. So I was a poor referee in that respect, but I was a good one in the sense that I tried to enter into the author's frame of reference and ask the clinician in me, what is this person trying to think about? Not what I'm thinking about. I mean, I can write my own damn article. What is this author trying to say? My task as a referee is not whether he converts me, but whether he explains what he's up to so that I can see, as the Supreme Court says, a rational mind being converted, even if I don't get converted. A lot of referees don't take their task that way. They seem to think that they're being asked, hey, Joe Almighty, do you believe this fella? No, don't publish it. Very strange way of thinking, very strange way of thinking. Or they write about all sorts of other things than the points that the article made. It's like book reviewers, you know, that write about somebody's novel that's not the kind of novel they would have written. And that's not your function as a referee. Well, I could make a big speech on journal refereeing, but I'll rise above the temptation. Imperfect realization of the particulars, and when that happens by maldescription, it has this problem that we mentioned earlier, that what makes faking data such a bad, gross sin, and that is that if we can't get behind the text in the way that we can analyze the mathematics and show that he made an error in derivation, or we can look at the numerical values and see that the degrees of freedom don't add up, or that some kind of a thing couldn't be squared with this part of the table over here. But when what is reported is wrong, isn't what actually took place in that lab, or is imperfectly described so that some things were done that are not in the text, we can't get behind the text, and that's why we have this problem of replication. Since we can't always get behind the text, our last resort is, can other people get this result or not? And if it turns out that other people consistently can't get it, then what we do if we can't explain how Jones got it, we just say, well, we don't know how Jones got it. It's like Dayton C. Miller, but we don't believe it. So we will not admit 01, 02 into the corpus, or we'll admit 01, 02, but we don't think that CN was adequately described. One thing you should be careful about when it comes to replication, there's a tendency to assume that the second author was always right. That's a very strange. Okay. I hope it's not a suicidal patient. What was I saying? Yeah, there seems to be this tendency to assume that if Jones published an effect and then Smith tries to get it in his lab and fails, that means that Jones rather than Smith was wrong, as if the time order somehow determined, as if the second try had to be the correct one. Now, of course, one is entitled to make the statement, this phenomenon appears not to be well replicable because I have a plus and a minus. That's all right. That means we got to do some more. But there's a very strong tendency to think that for some reason, the person who did it at T2, knowing that somebody got the result in T1, if the person who got it failed to get it in T2, then the first fellow was in error. I don't see any particular reason for assuming that there's an asymmetry there. It means that two people tried something and one got it and one didn't. We don't know what to believe at that point. Now, since the usual scientific habit is the leaning over backwards, don't buy in on affirmative assertions. I mean, why do we have that, by the way? Why do we have that? Well, we have that because science is a more successful operation than folklore. And we know that four-leaf clovers and walking under ladders and spilling salt, all of that junk, not to mention belief in unicorns and dragons and witches, arises because of not thinking scientifically. And that doesn't just mean thinking substantively like the scientist. It means collecting statistics, recording data at the time, finding out whether other people can see what you see. That's a pretty basic thing, isn't it? Science is a better enterprise from folklore and various other forms of human cognition because it has a set of procedures, and one of its procedural things is show me. I'm hard to convince. I'm leaning over. I'm from Missouri. Prove it. And so we have P05. Why do we have P05? And you might say, what's the matter with these Fisherians? Or what do they insist that you would get an effect that would happen only one time in 20? Why not one time in 10? If I do an experiment and I'm at the 20% level of confidence, my odds are 4 to 1. And the answer, of course, is that Fisher there was, well, it wasn't just Fisher. Before Fisher, Carl Pearson with the old critical ratio was just trying to put into numerical form the general scientific habit of mind, show me. Because if I go around believing everything that people tell me, I will end up believing not merely in valid physical theories, but in four-leaf clovers and spilling the salt and devil possession and witches and blah, blah, like that. I'll believe all of the nonsense that people have believed for millions of years and about disease and earthquakes and who knows. And if you begin with an empirical statement, which I gather some anthropologists don't accept, I can't imagine how it's possible, but they aren't here, the empirical statement that by and large science does rather well compared to old wives' tales or old husband tales, that it does rather well. And if your kid is sick, you call in the pediatrician and not the guy that rattled the gourds over him and so on. So if we start with that science by and large does rather well, and it gets us to the moon and stuff like that, we ask, well, why does it do rather well? Well, not just for one reason. That wouldn't be proper. It does better than some fields because of the nature of its subject matter, and because it uses certain kinds of instrumentation, and because it has calculus and probability theory, and so on, but also because the mental set of the scientist is that of the skeptic, show me. Now, in the context of discovery, the mental set of the skeptic is not necessarily the healthiest one. In the context of discovery, you should feel free to speculate and indulge in far-out possibilities and challenge the received tradition, and don't worry about whether you could prove it tomorrow. I sometimes think that we warp the minds of the young in psychology departments because we get you so damn scared that you might commit the terrible sin of not having a totally representative sample of the state of Minnesota, that students are reinforced in seminars where research is discussed, I find, not for being creative, but for pointing out that somebody didn't pool his degrees of freedom quite right or whatever. I mean, it's our fault. The faculty does this to you. We get your head fixed so that to not have a random sample is the worst conceivable thing a person could do. I remember the late Ephraim Rosen, who taught our Rorschach course, bringing me in a prelim once. He said, "You got to see this." And the student had talked about this particular experiment and said, not only was this experiment unethical, but it was even unscientific. Well, that's what we do with your heads. And the mental set is to play it safe so that the peer group won't think you're dumb or the faculty won't think you're stupid. And the way you can play it safe is to make the usual nitpicking statistical criticisms. I mean, that's always safe to say, was this a totally random sample of the Western Hemisphere's schizophrenics? And it's bound to work because it never is. And so you can get by with that and get reinforced. So in the context of discovery, you should be freewheeling. All of the writing by people who've made important discoveries is to that effect. I don't know of a single really brilliant mathematician or physicist who has written a book saying the way I made my discoveries was to shackle my leg to the chair like Hemingway writing for 4 hours before he could get drunk every day, you know. They don't write about it that way. People like Poincaré and those guys talk in terms of dreams and free associations and going fishing and well, the typical attitude in physics is it should be a little wacky. There's a famous quote from Niels Bohr about somebody's theory of the nucleus is the only thing I don't like about this is not crazy enough, and that kind of thing. Physicists are much less spastic than we are. They can relax because they know they got the best science there is, you know. Blow up the damn world, that's how good theirs is. And so they're very relaxed, you know. They're not stuffy and pompous about their vocabulary. They talk about charm and color and strawberry flavors in the nucleus. And we never would do that in psychology. If we had to talk about strawberry flavor, we'd look up the Latin word for strawberry. I mean, is it not so? It is so. So in the context of discovery, you should be freewheeling. When I first wrote my 1962 paper on schizophrenia, somebody asked me, Meehl, what did you base those ideas, where did you get those ideas? That was the way it was put. And I said, I made them up out of my head. Where do you get your ideas from? You know, what kind of a question is that? I mean, that's the worst form of inductive seepage, you know, as if the brainless and without ideation theory would soak up through your pores and so forth. So don't misunderstand me. When I characterize science as having the tough-minded, I'm from Missouri, that means in corroborating or refuting the theory. That's stage 2. It's not in the stage of creating it, and it's not in the stage of designing the experiments to test it, where you should be freewheeling. Let your hair down. Allow your creative spark to function. Well, so the test, the long-term test of this CN business, while in the short one we ask questions like, is Jones a careful investigator? Does his stuff from his lab tend to replicate or not? Can we see from the way the thing is written that it's a little slovenly? Those things we do take into account, and they are aspects of the context of discovery that we appropriately invoke in the context of justification, as I said before. But they're not the main thing. The main thing we have to rely on is replicate or not. Replicate or not. All right, number 5, inadequate power. I guess I don't need to say much about that because I've talked to you about Cohen's famous paper before. Jacob Cohen in well, I don't know, does anybody remember the date? 61 to early 60s. Did a sample of the Journal of Abnormal and Social Psychology and tabulated the power function for these experiments and showed that a very sizable percentage of them would have been incapable of refuting the null hypothesis at the 0.5 level even if the difference obtained had been a big enough one that presumably the investigator would have cared about it. That is, a big enough one that it would have been relevant to the testing or refuting of a certain theory. And so he said we should routinely see to it that we have sufficient statistical power to refute H null when we have a difference of a given size. And the way you find what that difference of a given size is to ask yourself what your theory would require for it to be corroborated by the difference. Now, the tendency is to think in soft psychology that a difference of any size at all is a good corroborator of a substantive theory, and I will beat up on that in a moment. But if I say that I'm really not interested in a difference less than a half a sigma, I'm interested in my theory of schizotaxia, and I'm studying neurological deficit in the first-degree relatives and the MZ twins of schizophrenic probands. And if I don't get a difference of a half a standard deviation on this steadiness thing, that is not a big enough difference to make me feel that I have corroborated my neurological conjecture, partly because of the alternatives, that people were a little nervous or something like that. And so I care about a half a sigma difference. I'd like it to be bigger than that, but if it's half a sigma or big enough, that big or bigger, I'll buy as a corroborative evidence of my theory. Well, then what I should do is either from previous research or a pilot study to get an estimate of the standard deviations of my schizophrenics and my controls on this steadiness test. And I don't at this stage require that that be a huge sample. If so, it wouldn't be a pilot study. I don't require that it be a huge sample or that I get highly accurate estimates of those two sigmas. But what I want to do is get I can either take them as they stand, or being a little more compulsive, set up a confidence belt, which after all you can set up with a small n. And say that the sigmas, I'm going to assume that the sigmas of my schizophrenics or my relatives and the controls are at least this small and this small. And if they are at least that small, not bigger than so-and-so, then I go to my t-test and I plug in as knowns those two sigmas, and the mean difference that I care about, or alternatively the mean difference that I got in my pilot study if it's that much bigger than the one I care about. There's no strict rule for how to do this, but the idea is I want to get the general lay of the land, how much they spread, and how far apart the means are, and then I put all of that, set t equal to whatever is at the 1% or 5% level, and what's left is the degrees of freedom. So I solve for my degrees of freedom, and then I say, well, this is a difference big enough to care about for my theory, and it looks as if I can safely say from my pilot study that the sigmas are not bigger than the following. That will mean that I have a pretty good chance of getting a significant result. He advocated, as I remember, a power of 0.8. Well, I know that some of you had statistics a while back, so let's just refresh your memory on the power function as to what it is we're talking about from the statistician's standpoint. We have no difference between the means, and that's the thing that gives us our exact test, as Fisher says. You don't have an exact test if you don't state a point value. And probability of reaching p equal to less than alpha, where that's our chosen significance level, say 0.5. And so what we're plotting is the probability of getting statistical significance. And along here is the actual difference delta of the means. I shouldn't say x bar, I should say mu parameter. This is the true difference between the means known to omniscient Jones, and this is the probability that I will get a difference with a pair of sigmas with my degrees of freedom that will be at the 0.5 level. So at this point, where H null is true, the probability of reaching level alpha is, of course, alpha itself. And now as the true difference between the two populations goes up, the probability of squeaking past alpha, of course, goes up. And if you have a very powerful test with 1 million cases, then just a little bit off will squeak you through. And so what we get is a thing like this, is a function of your degrees of freedom for fixed standard deviation and true difference of the two means. The complement of alpha is beta. Alpha plus beta equals 1. So beta is the probability of not squeaking through. And am I doing that right? Yeah, so 1 minus, this is 1 minus beta. And we have two kinds of errors that you worry about. The error of the first kind is to say that H null is false when it's in fact true. And the second kind of error, type 2, Fisher didn't talk about this, but Neyman and Pearson did. But in a way, Fisher clearly talks around it because he talks about the precision or the sensitivity. And so type 2 error is the mistake of sticking with the null hypothesis when you actually when in omniscient Jones knows that it's false. Okay. For a given pair of sigmas in the two groups and for a given true difference delta, the power function depends upon the degrees of freedom. So that what you're doing in your pilot study is to find out roughly what the difference of the means is that you care about, combining that or maybe with roughly how big it seems to be looking, and then roughly what the standard deviations are, and then you're saying, I will plug those into my formula for t and set t equal to the value that the t table tells me is at the 0.5 level or the 0.1 level, and that will, and I'll solve for the degrees of freedom. That's one of the reasons we do a pilot study, to decide how many cases we need in the big study to have a reasonable confidence of refuting H null when it is in fact false by an amount big enough that we care about in relationship to the theory. There may be some contexts in which you really don't care about statistical significance because it's wise to act as if the difference was at least in the direction you got. There's a famous little article 2 pages long by Herb Simon on that 30 years ago, taking, I think his example is a drug. If you run a study of 2 drugs, say sulfadiazine and penicillin for strep throat in kids or something, and the one appears to be better than the other, since the mean, or the difference of 2 proportions, since a proportion is mathematically a mean, the best estimate, both unbiased and an MLE, of the difference of 2 means is the obtained one. And then I might be well advised, if I'm a clinician, if the penicillin seems to be doing a little better for kids with strep throat, saves more of them from getting rheumatic heart disease or whatever. Even if the percent difference is small, a life is a life. When you're talking about delta P and talking about kids dying, of course, that makes us different from white rats not getting the maze right. And as Simon points out, it may be quite rational for me to pay no attention to significance tests in that instance. Other things being equal, I mean, if you don't have to worry about the fact that penicillin costs 12 times as much or whatever. If cost and spin-off disutilities like side effects are not appreciably different, then the best guess of a mean of delta is x bar 1 minus x bar 2. Unbiased estimator and maximum likelihood estimator. And if you go through life betting that delta has the algebraic sign you get, you will tend, of course, to be right, even if you never do a significance test. You will tend to be right. Okay, now those first 5 factors, loose derivation chain, problematic auxiliaries, doubtful ceteris paribus, imperfect realization of the particulars, and imperfect statistical power are all factors that tend to give a good theory a black eye. For instance, if the derivation chain is very loose, then if you're doing lots of experiments on a particular theory, or let's say many experiments on many different theories over your career, and you're always dealing with very loose derivation chains, then it will often be the case that O1 horseshoe O2 on the right doesn't pan out because, in fact, it didn't follow from the theory and the stuff you conjoined with it. And so there'll be and if you could have such bad luck, in other words, that if you were always working on true theories but with loose derivation chains, then frequently you would fail to get the O1, O2 thing on the right-hand side because it doesn't flow from the theory. It has to flow from the theory conjoined with all the other stuff on the left. And if that has not been made explicit, then this derivation chain doesn't wash, and so there will be a lot of cases of O1 tilde O2 that will make your true theories get a bad reputation. So these 5 factors tend to lead you, if you're a careful scientific thinker, to reject theories that are okay, either that they're literally true or, more commonly in psychology, that they have a lot of verisimilitude, because they will run up into these falsifiers. Well, now we come to things that go in the other direction, or at least usually. Number 6 is Likken's crud factor. I have mentioned the crud factor before, have I not? I haven't? Oh, well, then I told the counselors about it, see. The crud factor is Likken's term for the fact that in social science and biological science, but especially in social science, everything is correlated with everything. Even things that are not of any theoretical interest to us are not likely to be totally independent of one another. It is almost impossible to come by a Pearson R of 0.00 in psychology. You really would have to work at it. And I'm going to let Licken really grinds his axe here better and more effectively than I do, so I'm going to let him do most of this. But for my purposes, I'll give just a
You can figure it out from the armchair. It's bound to be true, but you know as an empirical fact that you almost never see correlation of 0, 0 in any kind of a table. Suppose I'm studying a male, female ability in color naming. And suppose that color naming is a linear function of a bunch of variables personality and ability variables, physiological variables, ranging all the way from partial degrees of red-green blindness to differences in focusing attention, to how much you paid attention if you were being confirmed in the Episcopal Church, to the color names that go with the changing vestments, and Baptists don't have those, and so on. I'll give you some goofy examples. You'll see that's not outlandish what I just said. Intelligence, verbal memory, identification with mother versus papa, because girls can wear, on the average in our culture, even today, they tend to wear more varied and bright stuff, and so it goes. And little girls are obviously reinforced for knowing that something is cerise rather than crimson and so on. Little boys are cerise, crimson, who cares? And now we have the situation that as between the two sexes, certainly in a sexist culture, but which all cultures are to some extent, as you know, from the anthropologists, in different ways. But even if that weren't true, even if there weren't this explicit role thing that a boy isn't likely to feel embarrassed, even if he's totally red-green blind, that he thinks something brown is green or vice versa. Even if it weren't for those extreme forms of shaping of the sex roles, if you think of all the different kinds of stuff in which experiences of boys and girls differ, and including verbal fluency and of talking earlier, and interest in this and that, that is not entirely a cultural matter. What a complicated set of things. Now, for these two means to be exactly the same in a color naming test, we would have to have either all these parameters be exactly the same for the two sexes, biological and social, educational, and all of the means of the variables that go into this equation identical, or what is equally improbable, that they weren't all the same, but that they were rigged just right to make up for each other. So that if there's a little increment delta A on this one, there's something a little bit smaller here, or if the mean here of this x is different, this one will have to be. It would have to be a Leibnizian pre-established harmony, wouldn't it, to get the two y means exactly the same. Now, don't fret me about the fact we care only about if they're sizable. I'm talking about H null. We're going to get to how big. Literal H null, all right? No sex difference in color naming. It's impossible. It's from the armchair. You don't have to do any research. You know that if you had 1 million males and 1 million females, and you all gave them all a color naming test, they would have a delta different from 0. In this particular example, it's not a negligible one. The color naming difference in the sexes in the old experiment is quite pronounced. Difference in the clerical ability score in the Minnesota clerical is just huge. Females have much higher clerical ability than males do. We don't know how much of that is genetic and how much is environmentally determined. So, H null is not going to be literally true in color naming between the sexes because, as Einstein said, God is subtle but not malicious, and we assume that that the big committee is not faking up these arranging this Leibnizian harmony in such a way that the difference in the beta weights is exactly counterbalanced by the differences in the means of determining causal variables.
I don't know how big the average correlation is between any pair of variables picked at random out of a pot. Somebody should study that. Licken and I did a little work on that, which is reported in that eternal Kronbach-Festschrift paper. Have I told you about the multiphasic MF items? What? I am really getting potty. All right. Well, we did two things. We got this huge sample that the Counseling Bureau collected some years back of something like 10,000 ninth graders. And we they had a H-page thing that talked about, asked things about what magazines do you take in the home, and what are your plans to go on to college, if any, and what are you going to major in, and how often do you go out on dates, and do you like picnics, and which shop courses did you prefer, sheet metal, electricity, printing, and so on. And certain family things like where are you in the sibship, and what religions do you belong to? We had a breakdown among the Lutherans as to whether they were ELC or Missouri or Wisconsin Synod or LCA. This started out because people spoke Danish instead of German and so on, that ended up with some doctrinal differences. I used to be a Missouri Lutheran, so I know all about this stuff. And we correlated all of these things with everything. I had 944 chi-squares we did. Everything correlates with everything. And we found that 94% of all those chi-squares were significant at the 0.1 level. And most of them were significant at the 0.00001 level because we had this big N, see? And some of them make sense, and some of them don't make any sense. But if you put a little ingenuity into it, you could explain all of them 20 different ways. Like, for instance, the Lutheran synods. This one kills me. What shop a boy preferred in high school was correlated with which Lutheran synod he belonged to. And you say, what is all that about? Well, I can concoct one there. You say the Missouri Synod. The Missouri Synod came over here in 1848, mostly fleeing from the unsuccessful revolutions of 48 in Germany. And they were, to some considerable extent, skilled workers, high-level proletariat, tinsmiths and factory workers and stuff like that, with a strong socialist leaning. So maybe they had genes and environment leading more to things like sheet metal and electricity, whereas the LCA or the ALC were mostly, like my ancestors, Norwegian yokels that came over here, not from a revolution, but because A, they heard there was good soil, and B, they didn't like the established Lutheran Church of Norway, and so, or Sweden, so they came over here, and they went more in, they were farmers and foresters, lumberjacks. The view was in the early days of Minnesota that a dumb Swede was good for nothing except to be a farmer or to chop trees down. And so maybe they're better at woodwork. I mean, I can spin one out. It's not hard. And so you can think of genetic factors, environmental factors, and so forth. And whether you can think of any specific theological factors, I can't think of anything about the Missouri Synod that make you like printing. Well, no, wait, I can do that one. I can do that one. The Missouri Synod was the most scholarly of the bunch. All of the clergy that I knew when I was in that outfit had 4 years of Hebrew, 4 years of German, 4 years of Latin, and of course the Greek. And so the tradition, despite the almost fundamentalist cast as regards the inspiration of the Bible and so forth, which led the outfit to come apart at the seams a few years ago, I predicted that one about 20 years in advance. I told my pastor, you watch, they're going to come apart at the seams. And they did, just over that thing. But despite that barefoot Baptist aspect of the Missouri Synod, very strong emphasis upon scholarship and upon intellect. Whereas some of the Scandinavian Lutherans were a little bit like St. Bernard, you know, that you shouldn't have too much G cooking here. I mean, you might start asking the wrong damn questions. So I can do that with printing. And it's not too far out. You connect this with words and type and Luther and blah, blah, blah. Well, anyway, it's obvious that a clever theoretician faced with this goofy set of chi-squares that we have could concoct plausible explanations for each one of them. Now, it might be a little tougher if he was going to try to concoct one explanation for the whole table, but why should you require that of him, you see? There's no reason for assuming in a field like psychology that one and the same kind of thing will be running through all of this. Well, another one we did was with the MF business. On the Minnesota multiphasic, there is a scale for femininity, and the items on that scale were item analyzed against the criterion group of gay males and also discriminating normal, quote, Minnesota controls men and women. They took those items from Terman, and only about half of Terman's items worked, it turned out, on our sample. On the other side, about half the items on the key were not from Terman's, but were other items that were, on the face of it, don't have anything to do with being male or female, or with your sexual orientation. Question: how many of the multiphasic items discriminate the sexes? 550 items. And if you've ever looked at the mult, if you haven't, you should. It's just an interesting set of items. And it's only partly psychopathology. A lot of it is not. Policemen are usually honest. I would like to hunt lions in Africa. Everything tastes the same. I feel like it was a tight band around my head. I'm a special agent of God. My family don't understand my friends very well, et cetera, et cetera. It's a very heterogeneous mess of stuff, deliberately built to cover the waterfront. Well, if you have a large sample, such as the Mayo Clinic sample, and you item analyze against sex, this is not psychiatric patients now. They're general medical patients who took the mult because they gave it routinely at Mayo for some years. Of the 550 items, I think there's only 27 that do not discriminate men from women when you have a sample that's large enough. I plan someday, or get some student to do a detailed study of Marv Donet's national drug data, which has, what, 6,000 or 8,000 subjects, and which he has all sorts of attributes of teenagers, religious, political, family interests, vocational, and things like that. So, taking just those two examples, which are extreme, but what you all know from looking at the journals, Licken is clearly right, and I have never met a statistician who disputed this at all, that in social science, everything is correlated with everything. So the next question arises, how much? Enough to worry about. Now the reason you worry about this fact of everything being correlated with everything is that if we imagine a big pot of variables, test scores, ability, achievement tests, special disabilities, personality, temperament, MMPI, strong, vocational interest blank, social, political attitudes in one pot. Introversion, economic conservatism, dominance, Snyder's variable, all this in this pot over here. And then I have over here a pot of theories. Festinger's theory of dissonance and so forth. And now I imagine that I pull theory T out of this pot randomly, and then I use random numbers and I pull two variables randomly out of this pot over here. So over here we've got Meehl's theory of schizophrenia, and over here we've got color naming ability and social introversion happen to come out. All right? And now we associate this variable pair, which came out of the fact pot, with this theory. And we arbitrarily say that, according to Meehl's theory of schizophrenia, there should be a correlation between color naming and social introversion. There is no logical connection between T and these two variables. I picked them out of these two pots in a totally random manner. Now I proceed like the usual psychologist, and I get a bunch of people defined as being high on one of these variables, and then I do a t-test or I do a correlation as to whether the people that were high and low on the first of these variables are significantly different on the second one. And I have said in this insane manner that Meehl's theory implies that there should be a correlation between X and Y. Now, the reason that the crud factor is something you should worry about is that in this goofy situation, when there's no connection at all between the logical content of the theory and the variables, if the crud factor is sizable, and if I have sufficient statistical power, then X and Y will be correlated, just as I, quote, predicted, even though the way in which I predicted it is in this goofy random fashion. So that if the crud factor is really sizable enough to be concerned with, if when you entered a pot of variables in a totally random fashion and pretended that some relationship flowed from T, you would tend to get corroboration of T. And if the crud factor were only 30 and you were always following Cohen's advice and being very careful that you had sufficient power, then you would always be corroborating T, even if it had no connection with the facts.
Just thinking about like the multi-trait matrix, some of the recommendations then that you find things that have negative correlations with the positive correlations with these kinds of things.
Yes, the multi-matrix method is one of the ways of trying to minimize the influence of the crud factor. Why it has not come into more wide use, I'm puzzled why. At the time that article was published, it was a rather direct outgrowth from their reading Cronbach and Meehl on construct validity and reading Jane Levenger's critique of our paper, and I was quite pleased with that, and it didn't take hold as much as one would like it to.
So what you're saying is in a lot of the research they're really not doing both kinds of
well, in the great majority of research studies in the soft areas, they are not doing what Campbell and Fisk said, nor are they doing a path analysis, which is another way of looking at it. In the great majority of studies in the soft areas, they are going about it with a traditional t-test or f-test of the variables that they picked. The exclusion of connections or the showing that something isn't related to something is as important a function as the showing that it is. And the bigger the crud factor is, the greater that concern should be. Well, next time I will give you some numerical examples to try to propagandize you or brainwash you to believe that the crud factor is probably big enough so that it's a source of real worry. Anybody came here late, there's another pass out.
Great.